Equations involve equating, or making equal, one quantity with another. For example, of all the numbers in the real number system, there is only one number that equals 4, and that number is 4. In algebraic terms, this involves a variable on one side of the equation, and the value of that variable on the other side. If x plus 5 equals 12, then clearly x must equal 7, since there is only one number, that when added to 5 is 12, and that number is 7. This is a very simple example. When it comes to more complex equations, the solution is not always immediately obvious. To solve algebraic equations, we isolate the variable by moving all non-variable terms to one side of the equation, or by balancing the equation. Looking at this equation, to isolate x we need to subtract 5 on the left-hand side of the equation. But, in order to maintain the integrity of the equation, what gets done to the one side of the equation, gets done to the other side. So, 5 is also subtracted on the right side of the equation. This is called balancing the equation. 5 minus 5 is 0, and 12 minus 5 is 7. So, x equals 7. In order to solve for x, we need to isolate the variable. To isolate the variable, we need to subtract 1 on the left side, but in doing so, we also need to subtract 1 on the right. So, 2x plus 1 minus 1 equals 5 minus 1, which means 2x equals 4. To find the value of x, we need to divide 2x by 2, since the coefficient of the variable is 2. At the same time, we also divide 4 by 2, since what gets done to one side of the equation, gets done to the other side. X therefore equals 2. To solve for x, we need to isolate the term that contains the variable x, which is 5x. To do this, we need to reverse all the operations that hold the equation together. So, the first thing we do is to multiply the quantity on the left by 3, to reverse the division. In doing so, we also multiply 19 by 3 in order to maintain the integrity of the equation. We now have 5x plus 2 equals 57. Now that the denominator has been removed, we can move plus 2 over to the right, and change the plus sign to a minus sign. So, 5x equals 57 minus 2, which gives us 5x equals 55. Finally, to isolate x, we divide both sides by 5, since the coefficient of the variable is 5. Thus, x equals 11. To solve this linear equation, we again need to isolate the terms that contain the variable. The fact that both sides of the equation contain the variable doesn't make this equation any more complex than what we have already done. We move all terms that contain the variable to one side of the equation, and all constants to the other side. It really doesn't matter how you go about this, but it is generally good practice to keep all variable terms on the left. So, we will move 13x over to the left, and minus 5 over to the right. So, 12x minus 13x equals minus 9 plus 5. Minus x therefore equals minus 4. Since the coefficient of x is minus 1, we now divide both sides by minus 1 to get x equals 4. To illustrate that it doesn't matter which side you move the variable terms to, we will solve the same equation again, but this time move the variable terms to the right, and the constant terms to the left. So, minus 5 plus 9 equals 13x minus 12x, which gives us 4 equals x, or x equals 4. In order to isolate x, we first need to multiply into each set of brackets, before collecting like terms, and moving terms across the equals sign. So, 5 is multiplied into the first set of brackets, and minus 1 is multiplied into the second set of brackets. We can now collect like terms to give us 7x minus 6 equals 8. We can now take minus 6 over to the right, giving us 7x equals 14. And since the coefficient of x is 7, we divide both sides by 7 to get x equals 2.